Welcome, my minions, to the next edition of our favorite math class. Today we are continuing with the same essential question, and our objective is a big objective, using properties of exponents to simplify numbers with exponents. And that's what we're doing today, where we're going to talk about quotients as fractions, something you probably already knew. I'm not telling anything new, but I'm going to tell you anyway. Quotients is the only vocabulary word I'm really using today, but we've already talked about it, right? You know what a quotient is: solution to a division problem. In division problems, you're used to seeing them more like this, right? That's what we've always done in this class so far, but they are actually most of the time written more like this, with a fraction line. Fraction lines just mean division, in case it never occurred to you, because sometimes things are obvious and then you're like, oh, that never occurred to me. Yeah, that's right. Well, there you go. So here's how we do these. Same way we do these. We just subtract the exponents. 10 minus 8. So you're still doing the exponent on top minus the exponent on the bottom. Okay? In this case, we get, what do we get? We get, 10 minus 8, 2, right? Okay. Let's see, I'll write that down. I'm just going to write down the whole thing, right? Like I was showing you before, 8 to the 10 minus 8, okay? Which gives us 8 squared. And if I want you to simplify all the way, in this kind of one, not too bad, you should have this memorized, 64. Okay. Look at another one. Same thing. I'm no longer going to be writing them like this over here. We're going to be writing them like this. So we're going to have 4 to the 5th divided by 4 squared. We just subtract these two exponents. So I'm not going to actually write out subtracting them anymore. I'm going to write the result. What is 5 minus 2? Of course, it's just a 3, so we get 4 cubed. We talked about squares and cubes. 4 cubed. This is one of those simple ones that we should try to memorize. And guess what? If you put it in your calculator or figure it out by hand, 4 times 4 times 4, you'll get 64. All right. I hope that made sense. Now show me what you can figure out. Okay, another one for you. Practice, practice, practice. Okay, so that was simple, right? A number on top, number on bottom, messing around with those exponents, no big deal. But what happens when we have more factors? Now remember, with multiplication, we add their exponents. So does that mean I add the 10 and the 10? I hope you're screaming at me going, no, don't do that, because take a look. The bases aren't the same. The rules. Got to keep the rules, right? We have a 7 here, but we have a 15 there. We cannot combine those two numbers that are on top. But take a look at the bottom. Hey, look, we have matchy-matchies. Matching bases there. Our 7s match. And look at that, our 15s match. Matchy-matchies. So we get to, let's simplify our 7s. And we're going to simplify our 15s. So when we go to subtract these, we're going to subtract 13 minus 10 to get 3, right? So it's going to be 7 cubed. But now the question is, where do I put it? The last one was kind of easy, but this one, what do I do? Well, this is actually just as easy. Look, where is the biggest exponent? The biggest exponent is in the basement. We're going to keep it in the basement, the result of our subtraction. So our 7 cubed goes in the denominator. Oh, I should maybe put that as one of our vocabulary words next time. All right, 7 cubed goes in the basement. Let's take a look at 15. 15 to the 10th divided by 15 to the 8th. So we subtract 10 minus 8, we get 15 squared. But where does it go? Ooh, bigger number up here, so we go up here. 15 squared. And for now, that's about how far I'm going to have you go with simplifying them. I'm not going to make you completely come up with a real number. I mean, a final number. You know what I mean? With no exponents. Unless I say so. I mean, if it's in the instructions or there's no choices except things without exponents, then you know. Keep going. But hopefully that one made sense. Here's another one where we're practicing with more factors. Let's see, but oh, wait a minute. We've got the 10 here. All right, that's not a 10. So we know we're not going to combine these two. But that's not a 10. How come it's not a 10? Oh, wait, there's the 10. Okay, there's one. All right. Thought I messed up. All right. No, I knew I didn't. 7 over here and 7 over here. Matchy, matchy, right? Bases have to match. So once again, 10 to the 18th divided by 10 to the 8th, which is actually 18 minus 8. Bigger number on top, so I'm going to end up with our 10 to the 10 on the top. 7 to the 10 up here. 7 to the 13 down here. So I'm going to end up with 13 minus 10, which is cubed again. 7 cubed. The bigger exponent is in the bottom. We're going to put this on the bottom. And once again, I'm just going to stop here. All right? I'm not going to require you to do it all. But if we did, if I said I want the actual numbers, no exponents, you'd write down that 1 and put how many zeros? You'd put 10 zeros after it. And then, of course, you'd put 7 cubed in your calculator and let it figure out and do the hard stuff. All right. Your turn. Be careful. Okay. Sneaky. I was sneaky on this one, so pay attention. Okay, so what happens when we have even more factors? Whoa, look at this. We've got lots and lots going on. We need to look for our matchy-matchies, first of all. Let's see what we got here. We got a 10 here, a 10 here, and a 10 here. Ooh, lots of matchies of 10s. Wait a minute, what else? Oh, I've got a 7 here, a 7 here, and a 7 here. Notice how I'm doing the lines underneath them to try to show you matchy-matchies. I could highlight with colors. You can do that. You could circle. There's lots of things we can do. All right, so what I usually do before I would worry about simplifying the 10 on the top with the 10 on the bottom, let's just simplify the top, which is called the numerator. Another vocabulary word I should have said. So up in the attic or upstairs, we're going to simplify and get our 10s together. As you can see, the 7 we can't yet, so I'm just going to leave the 7 hanging out. So 10 to the 18 times 10 squared. Now remember, 18 and 2, in this case, get added. All right? So it becomes 10 to the 18 plus 2 is 20. And that is times 7 to the 10th. We're not doing anything with that one just yet. Now on the bottom, I also, while I'm doing this, I like to try to make my matchies kind of come together or be, instead of all over the place. So I'm just going to copy, since there's only one with the base 10, I'm going to copy that, 10 to the 8th. Okay. Now let's look at our 7, our bases of 7. Down on the bottom, we've got 7 to the 13th times 7 squared. Times, we add, so it becomes 7 to the 15th. All right. Now we've got all our matchies matching, right? Now we can start getting into solving that division problem. So I'm just going to write it underneath here. I've got 10 to the 20th over 10 to the 8th. I'm going to subtract, and 20 is bigger than 8. So I'm going to put my answer in the upstairs. So 20 minus 8 is 12. So this becomes 10 to the 12th, and it's going to go upstairs. And I'm making it kind of long because I never know until I really look at it, where's my final answer and the other one going to go? Ah, it's going in the basement anyway. 10 minus 15 or 15 minus 10 is 5. So 7 to the 5 goes in the basement. And that's as far as I want you to go. How's that sound? All right. Your turn. Show me what you just learned. All right, even more factors. Ah! She's going nuts on us, people. She's going nuts on us. Well, let's look for our matchies. Let's see. Let's start out. We got a 10. There's a 10. Oh, and there's a 10. All right, now we got a 7 here. So let's see. Do I have? Oh, yeah. There's a 7. And there's a 7. Okay. And right here is a 5. Oh, there is a 5. Okay. So I'm just going to kind of like do 3 lines, since I'm going with the whole line thing. And wait a minute, I've got a 6 over here, but it doesn't have any matchies. Oh, the poor 6, he's all alone. But he doesn't get combined with anything. So let me show you what happens here. So like I said before, I like to simplify the top first with any kind of multiplication that's going on. So 10 to the 18th times 10 squared becomes 10 to the 20th. And I can't combine the 7 and the 5, so I'm going to hang on to them. 7 to the 10th and 5 to the 9th, and I'm running out of space, oh boy. All right. Now on the bottom, none of these match, right? 6, 10, 7, 5. I can't do a thing, so I'm just going to copy them, but I'm going to switch around the order a little bit so that I can see the matchies a little easier. Of course, and 6 to the 3rd. Oh boy. All right. Now we've got 10 to the 20th divided by 10 to the 8th, which means I'm subtracting the 20 minus 8, which will give me the 12, and they go on the top. Now I've got my 7 to the 10th divided by 7 squared, which gives me 8, right? 10 minus 2 is 8, and the 10 was the bigger number, and this is in the top, so 7 stays in the top. 5 to the 9th divided by 5 to the 6th. 9 minus 6 is 3. 9 is the bigger number. Wow, look how this one's working out. Fun stuff, huh? Now, took care of everything in the top, took care of all 3 of these. All I got left is my 6 cubed. It cannot combine with anything. So I'm just going to leave that poor little lonely thing down there. All his friends left. Bummer. Okay. After all that explanation, take a look at this and see what you can do with it. Well, guys, you survived another math lesson. Hopefully, this is starting to make more sense. We're going to practice, practice, practice. But I wanted to warn you, next lesson, look at the title, Powers of Powers. Woo-hoo! Lots of power going on here, people. Lots and lots. See you next time, and thanks for watching.